It is live now. You can start.
Okay, right now, how many participants we have?
It's 20 are there. You can start.
Vitesh, how many participants we have right now?
It's 20 are there. You can start.
Okay. Sure. So, hi, good afternoon, everyone. I, Aditya Pandey, core member of AWS User Group Dehradun, welcome you all to this enlightening and fun learning opportunity. As we have commenced our AWS Cloud Practitioner Training and present before you a plethora of certifications, practices, and exams to choose from and increase, enhance, and test your knowledge. And it is our esteemed honor that Mr. Sanchit Jain, a guaranteed AWS master and APN ambassador, will mentor you and guide you through this journey of learning. He has been involved in more than 6 editions of values conceptualizing the planning and building of applications delivered on AWS and the delivery of properly designed designs. He has a sound knowledge of most AWS administration and is widely involved in setting up a protected deployment phase in AWS using Foundation as a code. Amongst his various achievements, the following mention some of the most valued and appreciated certification earned by him. These are AWS Certified Data Analytics Specialty, AWS Certified Database Specialty, AWS Certified Solution Architect Professional, and many more. So if we see today, the solution architect positions in the IT industry are growing, and we will definitely start the solution architect training in future. But why we started this cloud practitioner training? Because we wanted everyone to be on the same chair, on the same seat, so that everybody grows at the same pace and reach at at that height. So we are very pleased to have you, Sanchit. Thank you so much, guys, for joining. So over to you, Sanchit.
Thanks, Aditya. Thanks, Achal, and thanks, Virat. I think this is really opportunity for me to talk to you guys about cloud practitioner and helping you out, right? I think Aditya, as you correctly just give a walkthrough and overview around the cloud practitioner. I do understand cloud practitioner is one of the basic one, but yeah, in order to climb a ladder, the first step is really important, right? You cannot jump directly on the second floor. The results, we everyone know what's going to happen, right? So yeah, it's really good that we start from the base, focus on the foundational, and then look forward to our journey, which is going through different associates and professional and specialty certification. Yeah. Before we start around the different agendas and all, just a couple of things I want to call it out, right? Please feel free to interrupt me, raise any questions. This is more for you guys for learning opportunity. So I'll want to make it more as an interactive sessions rather than just a person who's keep talking for an hour and there's no outcome, right? So please feel free to make it more interactive session. And two, today's agenda will be highly focusing on, cloud practitioner. Within cloud practitioner, we will be focusing on overview, like what exactly is this cloud practitioner all about, what you need to prepare or what you need to cover, right, as a part of this one. So that's what I think we will be focusing around it. So before we jump onto the cloud practitioner part of it, let me walk you towards this is a certification training and certification guide what we have. This training certification guide, which is easily available on AWS, on the Google. If you just search directly cloud practitioner, you will get this guide. I'll skip the first part. So I think this guide is generally talks about who's the targeted audience, what exactly you need to do, and other stuff. So the introduction is pretty good, as I think Aditya already called it out, who should be doing what and why this is very important targeted audience about it. But the important part is around the response type, that this questions is purely based out of MCQs. The MCQs can be either pick one out of 4 options or it multi-select kind of an options. It's not going to be more like an any kinds of hands-on lab that you need to do it in that case or writing a brief answer about it. It's more like an select the questions and you should be done. Multi-select type. The second important thing here which we need to understand is around the exam results, right? Results are very important for everyone. Outcome, whether it's positive or negative, but it's very important. So exam results are the score, which is like will be based out of 100 or 1000. Passing is somewhere around 700 plus, as it is mentioned. That bare minimum you need to get 700 to get the certification. But yeah, if you practice it well, if you prepare and focus, 700 should be an easy target to achieve. It should not be difficult around it. So that's one. And the next important section is the course outline. What exactly will be expected from you in the certification? This is very important that you follow this table. This table is elaborated, but let me zoom in. This table will help you from an overview from your curriculum for the certification. This includes 4 domains: cloud concept, which is like 26%, security and compliance is 25%, technology 33%, billing and pricing 16%. That includes somewhere around 100% about it, right? I would highly request, let's not go like our college curriculum kind of stuff that, okay, hey, this is 16%, so I'll skip it, or this is like 33%, so I'm focused. I would highly request, not for associate solution architect, even for your professional career, all 4 domains are very key and very important. May not be from a certification point here and there, but this all 4s are very good from a foundational perspective. And then if we zoom in a bit in each of these 4 domain, the cloud concepts, high level, it talks about what is cloud computing, why you should use cloud computing, what are different AWS services, regions, and all of the stuff, which is pretty much introduction to AWS services.
Hello.
What we have.
So sorry
Hello.
to interrupt you. Are you sharing your screen? It is not visible.
One second. Thanks for that reminder. 1 minute. Is my screen visible now?
Yeah, it is visible.
Okay. So yeah, thank you so much. Let me go ahead again. So this table is like the 4 domains, the key pillar of your certification: cloud concept, security and compliance, technology, billing and prices. So this includes your 100%, right? As I mentioned, please ensure that you do not skip any of the sections. All the 4 sections are very key and very important for you guys. May not be from a certification perspective, but maybe from your professional experience on AWS or the starting career. So this is very important. Please have thorough focus on all the 4 sections. If we dive a bit into each of this section, the first one, the cloud concept, more talks about what is exactly cloud computing, why you should be doing cloud computing, what is AWS, introduction about it, and different other, I would say, understanding more deep dive into AWS ecosystem about availability zone reasons and all. Then security and compliances, you talk about different services which are there for security and compliances. Technology, like what you should do, which A services, what you need to use, another thing, how you should interact with AWS console. And the last piece is around the billing and pricing, which is around whatever and however you leverage AWS Cloud, in what optimal way from a billing standpoint you should be putting forward to it. Okay. In specifically today's thing, what we will be looking forward is cloud computing, AWS, and services overview. And before we jump onto the one, right, let me introduce myself. I think Aditya has done a pretty good job of that stuff. Let me introduce quickly myself. So my name is Sanchit. I work as a lead architect at Quantify. Majorly, my responsibility is to work in and out with data and any sorts of platform solutioning it. And along with that, I also love to help people to get different certification, to help community. And with that area of interest and inclination, I also got privileged to be part of AWS Ambassador beginning of this year. And looking forward to work with you guys very closely and help you to achieve the cloud practitioner certification as soon as possible. So that's all about myself. Before, I think as we were talking about the introduction, right? So this we have already done. We have already gone through and understand what's exactly the cloud practitioner is. I've already given the exam guide link here in this presentation. This presentation, I'll share it with you post this section, but I'm already given the exam guide as well as some sort of a reference that how a question will look like, what can be the patterns around the same and other stuff. And today we'll be majorly focusing around the key parts that what should be the day zero when you're starting preparing for the cloud certification. Uh, Before then going deep dive into any services, I just want you to take a high level overview, 1,000 feet above. What are the different services? How those services have been categorized in Amazon? Which service does what in one liner? That is what we will be focusing in today's session. And then in upcoming later sessions, we will deep dive into each of those pillars, and then we'll do some demos and more hands-on. Hope that sounds interesting to you guys. Moving towards the next one, right? So this is around the introduction part of it, that okay, if you want to introduce, if you want to understand what's exactly the cloud computing is, right? The simple of it, right? Rather than going through the text part of it, what I'll try to do, right? I'll try to present this image. So as you can see, right, if I put a bit around this one, so as you can see, these are the servers. Now, this is simple to represent. These are the on-prem servers which are there available, the physical servers which are there in any data center, any machines. You can call your CPUs also one of the servers if you connect it to the internet, right? And install servers in it, then that's also one of the server. How exactly that works is you take it towards cloud, you connect them to the cloud, or you take it towards cloud, and then via that you can connect to your laptop or any device. And this way, the whole advantage of that is you can access it from anywhere. It need not to be that you need to be part of that particular network or particular physical location. It can be anywhere. Like simple example can be sitting here presenting you guys. I can also try to access one of the server which is hosted in my company's AWS account. That's the beauty all of about it compared to the previous scenario where I have to go to my office, I have to log in, and then I have to access it, right? Which becomes very difficult. Like the best way to understand, like in COVID times, now there is like lockdowns and other stuff, you cannot travel to your office. So it is very difficult that you go to office or one physical location and try to access and service, right? But there you see that why people or why cloud has picked up a lot in this phase is this underlying profit, which you see, or underlying benefit, that now you really don't need to be part of a physical location from anywhere, from any part of the country. If you have the device to connect a right device, you can easily take care of that stuff. So that's, I would say, in high level introduction of cloud computing will be in simple terms to understand about it. But if you go with a theoretical definition, then let me read it out. Cloud computing is a general term for which anything that involves delivering hosted service over internet. Cloud computing is an on-demand delivery of compute power, database storage, applications, and other IT resources through a cloud services platform via internet pay-as-you-go pricing. Now, the key part here to understand is this term, pay-as-you-go. Now, in case of on-prem system, or if we talk about the things which were before the cloud computing part, right? There were a couple of servers, big servers, which you have like around 18 GB, 24 GB, 32 GB, those kinds of higher RAM kind of heavy investment you need to do upfront. And based on that investment, then you have to do it, right? So it's what's not flexible pay as you go. It might be possible that you leverage 50% of it. It might be possible you need 150% of your thing, right? So quite unpredictable as well as very difficult to go. That's the advantage or the benefits of cloud computing is it's not only allowed to interact across any part from any part of the world, but it also provides this services as pay as you go. Like today you have like a requirement of 10 users, you have to pay for 10 users. Tomorrow you have 100, you pay for 100. So similarly is the model. It's very flexible, no upfront requirement, and that's more important to understand. And that is the primary reason where you see most of the companies, whether it's a startup, whether it's a mid-size, or whether it's an enterprise companies or enterprise giant Fortune 500 companies, everywhere, all the folks are some or other way been investing in the clouds. So this is the main reason of understanding, or this is the main key thing I would say, what is to understand the cloud. Again, the cloud computing are generally of three types. One is infrastructure as a code. The second is a platform as a service. And third is a software as a service. For now, I would request just remember this term. In upcoming slides, I'll explain you what exactly three of this means and what an example for it. Then it will be very easy for you guys to understand about the same. So as I was talking about the type of cloud computing in the previous slide, so this exactly is the difference of the cloud computing, I would say. The first column which we have is the on-site, which is more like your on-prem. The remaining three are more like an infrastructure as a code, platform, infrastructure as a service, platform as a service, and software as a service. Now, just remember this annotation. Blue dot means you are responsible to manage it. Red dot means that service provider manages. Now, what do you mean by service provider? Service provider in short is something like AWS, who provides the cloud offering to you guys. So they are responsible for it. So as you move from left to right, you will see that the red proportion is increasing it. That simply means that as you start shifting from on-site to infrastructure to platform to software, the people want to purely focus on writing your own business applications, your business logic, rather than really worrying about how the security is being handled, how the scaling of that particular infrastructure is handled, or how exactly the patch of the operating system is being taken care. No overhead of managing any sorts of infrastructure. You only purely focus of the application. Similarly, we'll go quickly through this, I would say, different columns. So if I talk about the on-prem, it's not just application. Like application is very key important, I would say. An application can be anything like any web server which you're running on, let's say on server, or any sorts of software which you're running, which you can treat as like an application. That application needs data to run, that needs an OS or a runtime, right? For example, if I simply talk about you're working on a Python web service, right? So your web service becomes an application, any sorts of database, let's say MySQL or any sort of a thing, it becomes your data. Runtime becomes a Python. Middleware becomes like an interaction, like a framework where you're interacting it. OS becomes, let's say, Ubuntu, Linux, Windows. Your virtualization is, again, I would say how you're segregating or dividing your compute entire stuff. Your desktop or your CPU becomes your server. The storage, the hard disk becomes your storage, and the last part, networking, the LAN or Wi-Fi becomes the networking, right? So this is how the entire thing it is. So in on-site or on-prem, you are fully responsible 100% to manage each and every part of it, right from writing the code to configuring the machine or to connecting the machines in the LAN. If you move towards the second column, you see 50% or roughly I would say 45% is already been taken care by the providers. Now, virtualization, server, storage, networking has already been taken care. Now, for example, if many people would have launched at least a simple EC2 instance. Now, in case of EC2 instance, do you really worry how that virtualization has been done, or where exactly your EC2 has been running, which location exactly it is running, or hardware, which hardware are you connecting? Like you're connecting a Toshiba hard disk, or you're connecting a Seagate hard disk, which hard disk you are connecting, or are you connecting to an RJ45 jack, or are you connecting to Wi-Fi, right? We really don't worry about that. We provide the configuration. I need 8 GB versus I need 16 GB. I need, let's say, T2 micro, or need M4 large, the compute power, and which operating system, and that's it, right? Simple what you do when you launch to EC2 instance. So similarly, you can see that this all 4 below layers have been taken care, and you worry about the other stuff, which is you select either you need which operating system, which middleware, which runtime, like you need Java, Python, or any programming language, which database, and which application. That's what you really do. If we talk about platform as a service, it abstract is much more further. You don't even need to provide runtime, middleware, OS, and all of the stuff. You just only provide the application. Okay, here is my application, here is my data. That also sorted out further. The last is software as a service. Everything has been given to you. You just leverage that application from your browser. That's as simple as that, right? Now let's understand the example, right? Because it is very hard to understand what has been having across each section. But once you understand the example, then you will be able to relate how this has been happening, right? So your infrastructure as a service, if we talk about from here, on-prem, you can consider any of the data centers as simple example, right? But in case of infrastructure, as I mentioned while explaining also, Amazon EC2 instance is one of the example where you talk about, right? There are other cloud partners also they have. But if I talk about AWS, Amazon EC2 is a best example where you have to worry, which falls under infrastructure as a service, where you worry about half of the stuff like your application data, OS, middleware, those kinds of details you take care. Platform as a service, Elastic Beanstalk, where you only worry about, okay, I have my Tomcat already been set up. You write a Java web service, you connect to a database, and done. You're done. You are ready to go live with Beanstalk. If I talk about software as a service, anything which is available in form of an API, like for a very simple example, in case of AWS, there are multiple machine learning services have been there. In very simple example for everyone, if I explain is Gmail, like Google Mail, everyone leverages. That is a software as a service. Do you really worry about where exactly it is running? Do you really about whether it's you need to scale it for 1 millions of user? Do you really worry about do you need to patch the server or you need to start and stop the server? No, right? You just go gmail.com and it works. So that is a best example, I would say, which is common for everyone on this call. Software as a service, right? So here are the 3 sections and the example of it. Now, if you compare this stuff, this table, what we have, this 4 columns with this example, then you will able to relate which exactly you will be doing. I mean, which is a better fit for you. Moving towards the next part, right? Now, I think so far it is pretty clear in everyone's head that, okay, what are the different cloud computings what we have, or where is exactly is the on-prem, right? Just to give you some more idea in terms of the bigger picture, why on-prem versus cloud computing. So in case of, as you see on the left-hand side, you have an on-premise network. In case of on-premise network, if you see the entire rock, you're not only worrying about the upper part, which is the application, but even the bottom part of it, which is training, maintenance, IT staff, hardware, customization, software license, and other costs, right? Very simple example, like if I give it to you is, you purchase a new laptop. Let's say now you purchase a new laptop, you pay for the laptop, whatever the prices you pay for it, that's an investment. You get training. Let's say you get a new MacBook and you have Windows. So you have to get a training. You have to maintain it. You need to also take care of other things like all the softwares have been there. You have proper policies, licenses and everything, right? Then warranties and everything. You ensure that if you don't have like a kind of a webcam in it, for an example, I mean, most of the laptops has it, but you don't have a specific hardware, printers and other stuff, then you get in hardware about it. You customize that laptop with getting right configuration of memory and all. And finally, you install software on it, right? A software on part of it, right? You can understand the kind of different activities which you do in order to do that. And if I take the same experience when you do it on EC2 instance, really neither you're making any investment, right? Upfront investment. You just pay for what you use, which is around just launching the server, ensuring whatever the requirement you need, you configure that. You customize it, like customize in terms of I need 16 GB RAM versus 24 GB. I need 50 GB hard disk versus 100 GB. That's what you provide the option on AWS console. And once that is done, you just try to install the application. Now, application can be open source or it can be whatever proprietary you need. And subscription fees is pay as you go model. What you pay, what you leverage, what you use is what you pay. So that is as simple versus thing of the first example where you have to get the laptop and set up and do other things, right? And same when it comes to availability part of it, if you need your laptop at 2 a.m. in the midnight, similarly, you can launch an EC2 instance also 2 a.m. So from an availability standpoint, there is not a difference, but you can understand the kind of different activities you need to do in order to get your laptop up and working versus the same thing what you can do in EC2 instance. And similarly, this was like a one-time picture, I would say. If I talk about the ongoing cost, the maintenance cost is always a difficult one, which people miss it out. Like you need to apply patches, you need to upgrade it. Now, in case of your laptop, it is very simple, right? You just download and done. But think of it that this laptop is connected to a production server. So when I talk about production server patches, it's not that straightforward. You need to ensure all your applications are up and running. There is a proper testing about it. If something goes wrong, you need to revert back to the previous version. So it's an overhead, a significant amount of overhead that you need to go through that, right? And again, the downtime, the performance tuning and all other stuff. So that's what I would say, full of different ongoing costs, which has been there right from and completely manual way, completely an overhead, I would say, applying patches, upgrade, downtime, performance tuning, rewrite, customizing it, integration, ongoing IT burden. You need to upgrade your network security databases. There is a common thing which I talk about, the on-premise. If I talk about the cloud computing, ideally, I would say in case of cloud computing, there won't be any sort of ongoing cost. Now, if I say ongoing cost, there are 4 pointers, right? Subscription fees, which is pay as you go. If you don't use it for 4 months, you're not paying for it, right? You have to ensure, but yeah, you need to ensure that you stop your thing. That's what is called as you're not using it. You need to train. That is simple. Like more people get added in your company or in your network, you need to train those people to use the EC2 or to use AWS, the stuff. That's, I won't say as an ongoing cost, but more like a investment which you're training or training part of it. Configuration, system administration. System administration, you ensure that your server is performing widely, properly, there's a proper monitoring has been there. So you're a bit prepared if something goes wrong for it. So that's what you just pay for it. So you can understand the very wide gap in terms of the overhead, cost, performance, and other factors when it comes to on-premise and cloud computing. If we move towards next one step below further, now so far we understood very well, and I hope that you guys have received it very well. What's a major difference between the cloud computing versus AWS, on-premise versus cloud computing? Now, within the cloud computing, let's zoom in a bit into AWS, right? So AWS, we all know that Amazon Web Service is providing the cloud computing to us, and that cloud computing is not just limited to the compute, but even to the database, analytics, application, machine learning. There is, I would say, somewhere around 200 plus different services are offered by AWS. I know there's a very large number of services. Don't worry, for the certification, there are very handful of that service you guys need to do. And again, I'm there to help you guys to simplify all of them, which will be very easy at the end of the course. So that AWS provides different services, right? Now, this 200 services have been provided for different broader groups of the people, right? Now, it might be possible there are, if I talk about our group of like couple of people, hundreds of people, I would say, the way we look AWS practice was be different between other 100 people. Some might be using some other services, some might have some other requirement to do it. Some other might be using, let's say, some other different sets of business application. So to ensure that they address the requirements of each and every user who's leveraging AWS, AWS provides a wide range of services. There might be a case where there are one or two services available for same use case because the case and the requirement of an audience changes from industry to industry. So that's the reason. Please do remember that. Otherwise, you might feel that, okay, I already have this service to achieve the same use case. Why I do need the second one of it? Okay. This next point around is how exactly the infrastructure, or I would say the footprint of AWS is, right? Which is very important. I would say this is the very key thing and very foundational part of your AWS journey outside the certification. What exactly the AWS ecosystem is. So first of all, AWS, if I talk about AWS is like how you can first look is like consider AWS as kind of like an application or any sorts of like I would say how I can put it like an entire world that say AWS has been there, right? The first step, how AWS has segregate its presence is regions. So you take AWS across the world, then you have one more layer at the bottom which is called as regions, right? Now, exactly if we read the definition is regions is a physical location in the world and is independent. What does it means is, let's say I have a region in Mumbai, I have a region in US, which is North Virginia, I have a region in Canada. Now, really it does matter, are they connected anywhere? Actually, these are all the physical locations, right? Mumbai is based out of India, North Virginia is based out of States of America, and you have one more regions in Canada. Are they really connected in any way? They might be connected from a networking standpoint for AWS, but are there any sorts of similarity in all three? No, right? So that's what it's saying. A region is a physical location. Yes, is it a physical location? And it's independent. Similarly, all these three are independent. Okay, so that's one region. If I talk about one layer below region, is availability zones, right? Availability zones is more like you can say as a data center, right? So availability zone is composed of one or more data centers. Now, for example, in case of Mumbai, there are 2 to 3 availability zones what we have. So bare minimum, each region consists of 2 or more availability zones. So now in Mumbai, there are 3. If I talk about North Virginia, roughly, I think there are 6 of them are there. So the whole idea of having this availability zone is a replica of the data center. So let's say if something goes wrong in a one specific area, which maybe let's say there is a flood, there is electricity disruption or any natural calamity, you have a replica available in another data center, which provides you the business continuity to ensure. Let's say, have you ever seen Amazon.in crash and it's not available, let's say for one day, right? It's not possible because how it is being, it's been built with highly available and with fault tolerance. That is exactly means that you segregate, you scale out in different geographical location. So if something goes wrong in, maybe natural calamity or from a technology standpoint in that particular data center, there are other data centers are present to serve that request. So we understood region, we understood availability zones. right? And then third point around is each region is connected with a very high bandwidth, fully redundant network. So which is pretty obvious that we understand that I mean the regions are very, I would say, thousands of miles away. Like one is North America, I would say America, one is like Canada, let's say Mumbai. There are others also. This was just an example we have in Australia also. There are all over the world, I would say there are regions are available. So therefore, sure, they have to be as lower latency as possible from a point, from a connection point. So that's one. Totally, there are 25 regions around the world what we have. And again, you don't need to remember the numbers part of it because this region keep increasing. Like for example, there is already a region which is going to start in 2022 in India itself, which is Hyderabad. So this is keep increasing because AWS wants to ensure that they provide a larger coverage to all of their customers across the globe and also force them or motivates them to build a highly reliable system. And the last point is the local zones. Local zones extend regions closer to end users, right? It's more like how I can define as like so far. I mean, Mumbai has its own region. I would say region like 2 to 3 years back. Before that, there was not a region. So how you can ensure? Still, I think I'm accessing like AWS from almost 5 to 6 years. There has to be some way still I was able to access, right? So there are local zones which are point of presence. That way you can ensure that AWS provides or extend closer to an end users. So those are the key terms. Remember around regions, availability zones, local zones. These are the key 3 things which will help you. And this will be for sure in your exams also, whichever you go, cloud practitioner or solution architect. Moving towards the next, this is more, I would say, zoom in view to understand, right? For your knowledge purpose, AWS spans across 81 different availability zones. It may be possible that by the time I'm just talking to you guys, there might be 1 or 2 availability zones more will be available. It will be 25 geographical regions, which we saw in the previous slide. 21 more availability zones will be added, and 7 more regions, including Australia, India, Indonesia, Israel, Spain, Switzerland, UAE. So you can understand, right? The kind of, and it's all about from a networking standpoint, the more number of regions you have, the more coverage you can give, the more you can ensure that people interact well with that stuff, right? One of the thing which is not important from a certification standpoint, but you want to understand, right? From a region perspective, you need to always ensure that, let's say, if your client is based out of United States of US, America, he will always ensure the data of his or her application stays in US. Similarly, if your client is based out of India, he or she will ensure that the data of that particular application resides within India, right? That is very key important that you have 1 or 2 regions. So this way you can have cross regions kinds of functionality also. That okay, something had happened, right? Tomorrow, let's say there is some sort of a riots or some sort of a flood or some disruption that happens in Mumbai. There is 1 more region what we have, let's say in Hyderabad, that provides you the cross region capability. So you at the end you can serve the entire application to rest of the world. So those kinds of thought process AWS has when you mean by 2 regions and why it is so important. Again, that's not required from a certification perspective, but just want to throw that light. And you can see the other different regions which are already accessible. As I talk about North Virginia, Ohio, California, Oregon, these are the actual states, I would say, in US. Then you have Cape Town. Then you have Asia Pacific, Hong Kong, Mumbai, Singapore, Sydney, Tokyo. So those, I would say, it's covered different parts of the world, and 7 more will be added here. As I mentioned, moving towards the next part is which region I want to select, right? Now I'm giving you like an option of 25 regions. So it is very hard to select which one I should do. I mean, obviously we'll say I want to select Mumbai because that's the one in India and I am sitting in India. So I'll select Mumbai, right? I would say maybe that is right or that is wrong. Ideally, it is very important. There are 4 criteria based on which you should select any sorts of region. The first is a compliance. As I mentioned in the previous slide also, compliance with data governance, legal requirement, like sort of data never leaves a region without your explicit permission. Now, if I want to ensure that my data should be sitting in India or my data should be sitting in Europe or US, there exactly you need to ensure that you select the region of that particular space itself, geographical. That's one. 2, proximity to the customer. This is a very key point. Now, let's say, for example, you host an application sitting in Mumbai versus you host an application sitting in US. It is very important that you select the place where you will have the users around it. That's two. Third, available services within a region. Okay, that's very important. Let's say whenever a new service comes in, AWS rolls out that services to a particular region where there is a need and the ask from the customer. For sure, that service will be replicated to other regions also over the period of time. Let's say if you have a rush or a business requirement, urgent requirement to work on that service, then select a region where that service is available. Okay, that's a simple one to understand. And the fourth point is pricing. Then based on the price, you select the one. Most of the cases, pricing, I would say, will be the least important one. But the first 2 points are very crucial. Compliance and data governance need, and second is a proximity, network proximity. Those are the 2 key points are there. Third, for sure, you will be taking care. If service is not available, you won't use that region. And the pricing. Pricing is very significant. I would say very small difference around it. But first 2 points are key difference. So please do remember that. Now, next part is around the way to interact with AWS, right? So in case of AWS, there are multiple ways you can interact. Very simple. You all would have accessed the console part of it for maybe creating S3 bucket or EC2 instance. That's a pretty straightforward approach. The second approach is from the CLI, command line. It also provides AWS CLI, which you can use, and you can do the same thing what you can do on the console. Like how you can list, when you just log into S3 console, you see the list of all the S3 buckets. Similarly, you can AWS S3 LS, and you can get the list of all the S3 buckets. The third point is API call. Need not worry, we'll have more deep dive example in upcoming sessions, but just want to give some high level overview so you can start thinking in that direction. The third point is the API calls. In case of API calls, it's exactly the same, but API call differs from CLIs. CLI is like more like a command line utility where you can do it. Let's say if you want to interact via some sort of programming language like Java, Python, Go, .NET, there you can use AWS call. The same thing. If I want to list, you just create an object of that S3 SDK, then you initialize the client with the right credentials, and then you call that particular API. But these are the 3 mediums via you can access the AWS or different services which are there in AWS, right? The different features which are there is easy to use, flexible, cost-effective, scalable, high performance, and secure. Let's understand each of this thing, right? Easy to use. Now, for sure, it is easy to use. Which medium you're comfortable with, you can easy to use it. If you're good with console, you can use with console. If you're good with CLI, shell scripting, you can use with that. If you're good with API calls like Python, Java, you can leverage that programming medium. So whichever and whatever your comfort zone is, you can leverage the AWS services in that fashion. 2, it is very flexible. Flexible, if I talk about in very simple ways, you can customize the way you want to deploy. Let's say if I want an EC2 instance of Windows Server with 80 GB of hard disk, let's say 16 GB of RAM, all those options are available. I mean, if you go for certain times, it might be possible that when you're getting a laptop, those configuration may not be available. But I'm 100% sure if you're going to launch an EC2 instance, any configuration which you need will be easily available in that EC2 option. So that's cost effective. Third is scalable and high performance. It's highly scalable if you talk about from networking, if you talk about from the compute or any sorts of services. It's highly scalable and highly performance, right? You can use things like auto scaling, load balancer to scale up and scale down these services as per your requirement. And last is it's very secure also. AWS utilize end-to-end secure and hardening infrastructure, physical and operational and software images, right? I think it's very difficult to even get into the data center of AWS if you're not part or you're not working as an employee there. No one is allowed, not even Amazon employees have been allowed to go there unless you are working in that data center. So those kinds of securities have been taken care. And from a pricing standpoint, pay-as-you-go model, and there are discounts also have been there. Pay-as-you-go model is very simple to understand, per second billing. If you're using any service for, let's say, 5 minutes, based on the seconds, 300, you have to pay for that. Discounts, there are various ways you can reduce your entire consumption billing, like you can use saving plan. If I talk about, let's say, EC2 for an example, you can use things like committed usage, sorts of spot instance or saving plans. There are multiple such options are there, which we will deep dive into EC2 pillar. But there are other ways also to get more discounts based on what you have already leveraged. So that's about the three key things of AWS. And from a pricing standpoint, I think I've covered in the previous slide, but just to focus a bit, because this is very important that you understand the pricing part of it before you start, let's say, spin up a new account or start understanding about this one, right? AWS has a three pricing model, three pricing fundamentals. Following our pay as you go model, then you have pay for data transfer cost and pay as you go for other compute standpoint, right? So when it talks about the compute, you have to ensure that pay for the compute time. Now, for what this means, right? Let's say I'm launching an EC2 instance. I have that EC2 instance up and running for 45 minutes. Now, in that case, what is the billing I will be paying to AWS? Will I be paying for 1 hour or will be I paying for an entire day? I will tell you, neither you're paying for 1 hour, neither you're paying for entire day. You're only paying for what you have on. So let's say even if you keep it on for 40, not even 45, if you keep it on for 44 minutes and 60 seconds or 30 seconds, that's what you're going to pay. Not even completely round off to 45 minutes. So that kind of detailed granular pricing it provides. Second is the storage. Pay for the storage cost. Now S3 is very cheaper in terms of the storage, right? Like it's, I would say the best service in AWS from a cost standpoint and scalable is the S3, which we know very well. Everyone knows about it. From pay standpoint also, you're not paying any upfront price, right? Certain of the providers provide that, okay, we will provide you 100 GB of, X hosting compute and 100 GB of storage space. Beyond that, you might have to get, let's say, pay additional dollars or pay additional price and you will get every 10 GB. Those kinds of things are not there. As you start putting it, even if you pay for if you have 1 KB of file or you have 1 terabytes of file, the size of the file and the way you have there, you're paying for that stuff. In case of data transfer, which is very important, the data transfer out of the cloud, right? So data transfer in is free, for the out you have to pay for the cost, and solves the expensive issues of traditional IT, which we understood very well that, okay, you don't have to have like an upfront investments and other stuff. You only pay what you use. So these are the key things when it comes to the pricing part of the cloud. Now, this is also one of the important thing for your exam itself is also AWS acceptable use policy, right? So there are a couple of things which you need to take care is no legal, harmful, or offensive use or content, no security violation, no network abuse, no email or other message abuse, and there's an entire policy that has been given here on this one, right? Now, for example, there are a couple of ways you interact with AWS or AWS support guys also, right? So you need to properly ensure that there is no illegal, harmful, or offensive use or content. There is no security violation, no network abuse, right? What it means, right? Now, there might be a question that how we can abuse the networking part of it, right? So basically, let's say, for example, when you have like a production scale, certain times you do a security checks like penetration testing and other testing to ensure that your system is built with proper security in place. So in that case, what you do is you intentionally try to be an hacker and you try to hack the system which has been deployed on AWS. In such cases, AWS do allow such kinds of testing, but to ensure that you properly inform upfront to AWS, take an approval from them, and ensure what resources are under that security scanning. But if you don't inform them and directly do it, then that's a violation here of security as well as network. Similarly, no emails or other abuse messages. If you're interacting with any support person or any sorts of humans from AWS side, you have a proper talking point with them or proper exchange with due respect. There's no abuse messages and other stuff. And more details have been given on this particular link if you want to deep dive and understand in detail. Okay, so here we understood, I would say, the major introduction part of AWS service. The next section is the one which is very important. So what about all of the AWS services across different pillars? But I'll take a pause of a minute to ensure that do you guys have any questions so far?
Hello.
Hello.
Sir, could you able to see the question on your screen?
1 second. Yeah. Okay, we have so many cloud service providers, then why we need to learn AWS? That's a good question, right? Now, I would say there are many cloud service providers which are there. In case of AWS, the unique part, as I mentioned, right, in my explanation also, AWS not only just address one particular community, maybe some XYZ kind of business application, it is meant for a larger, broader people, for the broader community, right? So that what brings the additional or the key benefit of learning AWS, I would say, outside to other kinds of different applications or different complex application you can build, right? So that's the important part of it. Does cloud computing really cost less? Exactly, like very simple of it, right? How I can explain you now? Very simple. We all have a mobile, right? Now you're getting an iPhone. Now I tell you that, okay, hey, you need to get an iPhone. So for sure, we all know that iPhone will cost you like $60,000, 60,000 rupees minimum. That's one option to do. Or I ask you that, okay, you pay me weekly basis, and whenever you are done that, okay, I don't need this, you give me back. For sure, the option of weekly base will be much more cheaper. I don't need to pay upfront cost, and it's what only I'm paying. Like if I'm using it for 1 week, then I'll pay for 1 week. If I need 2 weeks, then I'll pay for 2 weeks. That's a simple example. I would say that cloud computing is really cost us less. That's one. Second is also you don't need to invest in any sorts of resources, like from wear and tear of any sorts of networking or any sorts of hardware devices. Because worst case scenario, if your EC2 is not working as per expected or it get crashed, you shut it down and you relaunch it. So that's the reason cloud computing is not only cost less, but it's also from an overhead standpoint is very beneficial. Could you explain more about the billing process? How does that work? Yes, for sure. I will have more deep sessions in upcoming. Have deep down into billing and the details in upcoming sessions. But just for to introduction standpoint, you have to remember that okay, you pay as you go model. That's I would say the thumb rule when you leverage AWS. That you only pay for what you use, irrespective whether you're using a serverless application, serverless services, or you're using any sorts of stateful like EC2 or any sorts of database. But we'll have a complete detailed sessions in upcoming weeks where we not only talk about how billing process works, but even how to have more wider visibility of the billing and how we can have a proper proactive measures to optimize it. But I'll park this question for the upcoming sessions. Sanchit, could you please explain about data transfer with an example? Okay, that's a very good question to hear. For example, everyone would have used a database, right? The database kinds of stuff or any kind of service, right? You make a request to something and you get a response. Very simple example. Anything which you make as a request is called as data in. The response which you get is data out. So this is what a simple example I would say of the data transfer. So let's say I am firing or I'm making a call to a database that is data in. The response which I get from database standpoint, it's a data out. So I only pay for the data out part of it, not the data in. That's an example I would explain when it comes to data transfer. Last question. We have one more question. Which platform is more user-friendly, Azure Portal or AWS Console? I would just put it out in this fashion. Ideally speaking, irrespective of which cloud you're going, console is not the right measures. Console is good for the folks who's just starting their journey on the cloud. If I talk about myself, honestly, I have not logged into console like almost like 2-3 months back outside the different meetups what I have. Because in case of actual production or day in, day out, we use CLI and the different SDKs. Because very simple of it, I'm building an application. You're not going to ask an end user. You go log into console and then you access that application, right? You will have a kind of an UI in front of it or some other way via a user can access that application. So that's why portal, I would say, really doesn't matter. But if you ask me honestly, my bet is always AWS because the way, I'll walk you through also, right? The way they have categorized the different services into different pillars, that cleanliness really matters a lot. Look and feel for sure, but that organizing those services and a hierarchy of those services is key understanding that whether even someone explaining you from that pillar itself, you identify that okay, what kind of service you're going to get in this pillar. So I think that's all of the questions. Let me switch back. Let me share my screen and let me switch back. Okay. So as I was talking about, right, that from a service standpoint, the best thing which I personally love about AWS is the way they have categorized all the services. So this is what we will be focusing in this half of the session is the different services. As I mentioned, they have somewhere 200 of plus services. They have segregated into different sections of it. The first section is compute and serverless. Ideally, I would say compute and serverless is, in simple words, is any service which provides you the processing capability. The couple of services which are there is EC2, Elastic Beanstalk, AWS Lambda, AWS Batch, Lightsail, and Workspaces. Okay. So very simple. I will explain you one liner also, and I intentionally have given you this description here, very simple description. So once you get this presentation, you can also read before our next session. So when we go deep dive in each of this pillar, you really have better understanding, not just only the name of the services, but you understand why that services has to be used. This is more important to understand. EC2 is very simple, right? It's kind of an infrastructure as a service, which we already saw in the previous slide. It gives you multiple option to host kind of a web application, any sorts of UI application. You can write any programming language in that one. It's more like a virtual server, I would say, on the cloud. So that's about EC2 instance. Second, if I talk about the Beanstalk, Beanstalk is more like a platform as a service, where if you want to, let's say you have a kind of a Java-based any web service, which is written in servlets, for an example. And if you want to deploy, now I know very well it's a servlet, is already going to run in Tomcat, and I don't know about Tomcat, let's assume. Then in that case, Beanstalk help me that I really don't need to have a knowledge about Tomcat. If I know servlets and servlets is working fine, you can deploy in Beanstalk just by selecting, okay, you have to run this particular program in Tomcat. So you don't worry about not the infra, but not even the web server kind of the stuff. So that's a Beanstalk. The second one, what we have is the third one, I would say, is a Lambda. I think the Lambda is very renowned service to everyone, which is a serverless, that you really don't worry about the server part of it. That's no server, actually. And the pricing model remains the same. And here you purely focus on your functional part of the world, that you write your pure programming logic without worrying any sorts of OS, infrastructure, or any sorts of other thing. The remaining three services, I would say, is more for your knowledge purpose. But the first three are the very widely used. If I talk about AWS Batch, it is very used in industries. Let's say I have certain things which certain processes which I need to do in a batch mode. For example, I have millions of images. I want to convert those millions of images into thumbnail in one go. In that case, what I do is I spin up an AWS Batch and I tell AWS Batch, okay, hey, here is my S3 location. I have millions of users. Here is my Docker image, which has my code. Can you process all those images and give me in another bucket the thumbnail? So what it does is it takes all these millions of images what are there, and in a batch mode, in a collated mode, it just start processing and start putting it into the stuff. So it is best for dynamically provisioning the optimal quantity and type of compute resource based on the volume. So as I mentioned, the volume part of 1 million, right? So based on the volume, it internally handle all other stuff. So I don't have to really worry about that thing. A light sale is more like, let's say if you have any sorts of, it's for like a starter person. If you have any sorts of web application, website, which you want to host on monthly basis, and you really don't understand the other part of technology, but you just have a website which is running fine and you want to host monthly basis without worrying about the other integrities, then light sales works well in your case. And the last is a workspace. Amazon Workspace is more like a virtual desktop, VDI, virtual desktop interface on the cloud. In simple language, if I explain, it's like I take this laptop and put it on the cloud. That is what is workspace. And from that workspace, I can access from any part of the world. So that's what is workspace. Moving to the second one, which is around the database. I think we know very well about the databases, which is a common thing: MySQL, SQL Server, Oracle, Postgres. This is a common, I would say, different vendors or different databases are available. Similarly, in case of AWS, there are 5 different things are there. Relational databases, which includes the same thing. Your Oracle, SQL Server, Postgres, those kinds of different databases have been provided, I would say, underneath RDS services. The key thing is Redshift. The Redshift is like an enterprise warehouse which has been offered by Amazon. It's a very good and widely used services, I would say, on industry enterprise side when people want to build like a warehouse system. I mean, say a more complex analytical processing system, then that is called as Redshift. Ideally, for your understanding, there are 2 types of system are there. Transactional, which is called as OLTP system, and OLAP. OLTP is more like a transactional system, daily in and out. OLAP is more analytical purpose. Like if I want to do an analytical stuff workload around it, then I will use somewhere like OLAP, which is like a warehouse kind of a system. If I want to use more like a transactional, day in, day out transactional system, then I will use any sort of a relational database. So do remember that kind of a difference. It will be really helpful. The third one is a DynamoDB. Now, DynamoDB is a NoSQL offering of AWS. There are other new services that also has come up, like DocumentDB. If I talk about, there are other things are also there, but from the certification perspective, I want to specifically focus on DynamoDB. The other services we can deep dive in the next certification, like Solution Architect, or we can have another sessions for that one. The fourth one is Amazon Aurora. Now, Aurora provides optimized version of MySQL and Postgres. Now, the question can be, again, the same thing, right? The RDS also provides the same thing. Aurora also provides the same thing. Then what's the difference? Aurora is more of an optimized version of it. So it is not 3 times faster, but even from a cost standpoint, it is less. It will give you the 1/10 of cost and 3 times faster. So it's a more of an optimized version of even RDS for MySQL and PostgreSQL. And the last one is Elastic Cache. The name suggests it is very easy for any sorts of caching activity. It's Elastic Cache. Like if you want to, let's say you're playing any sort of gaming or any sorts of other stuff and you want to cache the response, there you use Elastic Cache. So this about the database. The next part is the developer tools. So when you work in industry, right, I think that was one of the question also. Hey, which console works well? So I told you guys that generally in enterprise or in day in, day out, you do not use console. The reason is because of this. In IT industry, when you're working on any projects, you use the developer tools, which is generally called as automation, infrastructure as a code, like CloudFormation, CI/CD. Those are the different tools of DevOps, what you use day in, day out to simplify the entire operational cycle of it. So here are the 4 services that helps from a CI/CD standpoint, which is continuous integration and continuous deployment. So things like code commit, code build, code deploy, code pipeline. Code commit, for simple example, is exactly like a Git-based repository. Things like GitHub, GitLab, Bitbucket. You would have used any one of them. If I want to see a similar version on AWS, it's called as code commit. Code build is like you have your Java code, right? Someone would have already tried to deploy the Java code on Tomcat or a kind of a Python code in any sorts of Django or anything, right? Ideally, what you do is in Eclipse also, when you have Java, Eclipse create a war or a jar file of it, and then that war and jar file you deploy in Tomcat. So there's a build process. Build is nothing but packaging process that takes place. This code build is that service which package your raw code into deployment or deployable artifact after running all sorts of testing and other thing. There, the code deploy is more like a deployment service. Let's say, for example, you already have spin up an EC2 instance. Now you want some automated way to deploy your war file, which has a servlet code, into your EC2 instance. So their code deploy will help you to deploy that entire thing. And then code pipeline is more like an end-to-end pipeline. So right from a person or you push the code to building that code or spinning up the infrastructure and making the deployment, GitLab code pipeline automates that entire deliverable cycle, I would say. So here are the 4 different services what you have from a developer tool standpoint. Next, what we have is around management, monitoring, and governance. This is, I would say, is a very important point, and please focus on this one. The first underneath is CloudWatch. CloudWatch, in simple terms, is very helpful from a monitoring standpoint. You can monitor the application, understand in response to performance, any sorts of optimization that you want to do in resources, optimization, underutilization or overutilization, any sorts of change in the utilization, or collects any sorts of operational data in forms of logs, metrics, and events, right? For example, let's say you have an EC2 instance. If you want to understand in last 24 hours, what was my CPU utilization of that server, that visibility you can get from CloudWatch. Okay. Moving towards the next, which is the Cloud Trail. Now, Cloud Trail is very important to understand. Now you want to understand, right? That, okay, I have spin up my AWS system, but I want to know which user was doing what kind of an action on AWS. Let's say person X created an S3 bucket, person Y created an EC2 instance, person Z deleted the EC2 instance. So that kind of entire detailed logging or tracking has been done by the Cloud Trails. Okay, so any sorts of API level tracking, do remember the word, any sorts of API level tracking will be handled by Cloud Trail. Any sorts of logging is taken care by the CloudWatch. But these two services are very important in any of the certifications you go forward. The next one is AWS auto scaling. The auto scaling is very simple of it. Let's say I deploy my EC2 instance. I'm assuming that today I will have only one user and I deploy my EC2 instance. Tomorrow, let's say on second day, there are 10 users. On third day, there are 20 users. And fourth day, again, there are one user. How I can customize the entire need here, right? I cannot keep sitting and launching my EC2 instance every other day. There exactly auto scaling helps. Auto scaling will replica that instance based on the defined metrics you provide, right? There are two parameters which you give, minimum and maximum. Based on that parameters, auto scaling takes care of launching the replica. The next one is AWS budgets. AWS budgets is very important. Let's say, each one has a budget, right? Even debit cards and credit cards and all those has a limits. This similarly is a limit in forms of your AWS billing. Let's say I tell that, okay, this month my budget is going to be $100, or in simple language, 6,000 rupees. So what budget does is you can say that, okay, my budget is 6,000. So, and you can set the different levels of it. You can send me a message or notification at 10%. You send me a notification 20% at 50%. So you have a proactive way to ensure that what you are consuming on AWS is not over surpassing your budget. The next point is the cloud formation. I think everyone knows about the cloud formation. It is the way that you can automate the entire infrastructure. Let's say you launch in one EC2 instance, you will easily love to do it and go and manually. But if I ask you that you have to do this every day, your job is just to launch, keep sitting and launching EC2 instance every hour, you won't like it, right? First day you will love it. Second day you will love it. But let's say over a month, you will get fed up that, okay, what is this happening? Every day I'm coming and launching an EC2 instance itself. There exactly cloud formation comes up. Cloud formation is a way to automate your spinning up infrastructure with all sorts of configuration what you need. Let's say I want to launch an EC2 instance with, let's say, Python installed with Java installed. You can easily take care, you can have this entire script there in the user data section of cloud formation, which takes care of the entire thing. Not only just spinning up the infrastructure, even if you need any software in that. The next point is AWS config, right? So AWS config is more like an auditing services. That, okay, if you want to audit that, okay, how many S3 buckets has the accessibility for a public? That kind of stuff you can do via AWS config. Config will help you to scan all the resources which are there in your account and come up with an exhaustive list. The next one is around AWS cost and usage report. Again, don't worry about it. Just try to understand the description and the description of the services and what that service offers. We'll understand this in detail in upcoming slides, right? So cost and usage report is like, let's say what kind of cost I'm doing. Let's say I have run EC2 instance for 10 hours and it cost me 500 rupees versus I have also launched in Lambda and after number of requests of Lambda, it cost me 10 rupees. So those kinds of service level tracking as well as the cost is what being given by the cost and the usage report. That what is the cost and what is the usage of that each service level, what I have leveraged. The next is around the AWS organization. AWS organization is nothing but like I would say, consolidated way of looking around it, right? Let's say you have main, simple of example can be a tree structure, right? You have a root node then you have a parent node, then you have a child node, right? The simple binary tree, those kinds of stuff, right? What we have understood in algorithms. Similarly, organization is nothing but the root node here. That it's a master account. In that master account, you get an organization unit as a service, which help you to track, to organize and to spin up different other child accounts there. And then from a billing standpoint, you only get charged on the master account, not the child account. But you do have a proper visibility. Let's say what was the cost for child account A versus what was the cost in child account B. The next one, what we have is the secret manager. Secret manager, let's say you have certain sorts of credentials, you have any sorts of API keys, those kinds of things you can store in your secret manager, and you can ensure that only limited person can have the permissions, or if you want to even rotate after it get expired, those kinds of things are being provided by the secret manager. The system manager and parameter store, I'll couple it together. System manager is more like to view the control, right? For example, let's say if you want to patch any sorts of application, any sorts of services, upgrade, let's say Python from 3.6 to 3.7, those kinds of things you can do in system manager. Whereas parameter store is, let's say, there is certain kind of a parameter value which you want to use across 4 different programs. Let's say there is a value of pi, okay, 3.14 for a very simple example. This value you want to use across the 4 different Python programs, and this Python programs have been running in 4 different machines. Now it is very important that this all 4 machines should be able to look up at one central place. Now you can have S3 also to do it another way, but what can be the fastest way? And you can ensure that the proper tracking is been there, right? So that what they do is you can store that pi value, or for an example, any value in that system in the parameter store, and it can easily be accessed by all the EC2 instance. I mean, this was a very simple example. This ideally what people generally do is any sorts of configuration, like environment wise. If you have dev environment to production, right? Different environments you have. So all kinds of stuff, like for example, what will be my S3 bucket? Now S3 bucket is global. So what you have in dev environment, you cannot have in production. So similar kinds of configuration details, environment level, you can store in the parameter store. The next one is a trusted advisory, which is like a recommendations which you get, right? When you have trusted advisor, it gives you a recommendation that, hey guys, you have 50 EC2 instance. Out of 50 EC2 instance, you have 30 instance where the EBS volume is higher than utilization. Like what you have provision, the utilization is not that. So there is a chance that you can optimize the cost. So those kinds of recommendation you get from trusted advisory. The next what we have is the API gateway. Now API gateway is more like an endpoint service where you can plug with Lambda and build like a microservice kind of a stuff. So it helps you to manage and publish and monitor your APIs around the same, right? The next one is the CloudFront. CloudFront is more like a CDN. The best example of CDN can be caching. Let's say, for example, you're watching a video on YouTube, right? Do you think that it will always go to some location, some storage where the video is stored, and it will bring to your laptop? Ideally, no. What it works, it's like a cache. So first time, let's say when you send a request, I want to watch XYZ movie. So it will check the cache. Does this movie exist in this cache? If yes, then it will directly stream from that cache. If that movie does not exist, then it goes to the actual server location, get that movie into the cache, and then stream it to you guys. So this way, if second person try to access the same movie, it can serve from the cache. So this caching front is called as a cloud front. This is very important if you're building any applications, right? From a proximity standpoint, like today you have 10 users sitting, let's say in Mumbai, you have 100 users sitting, let's say in other states. So if you want to cache and have more improved performance, then CloudFront can help you. Direct connect, very simple of it is for your understanding. As we talk about the on-prem on the cloud, there are certain applications which will still run on-prem still if you move to the clouds, right? Because they are legacy, and before you move them to the cloud, you need to ensure that they are up and running, right? For a very simple example, let's say we are working with any of the bank. The bank already moved towards the cloud, but there are existing records, existing things are there which they want to continue providing to the end user. In that case, there should be a bridge, networking bridge, right? That allows you to connect from AWS to on-prem and from on-prem to AWS. That bridge is called as direct connect. The next one is the Route 53. The Route 53 is more like your DNS service. Let's say, generally speaking, what you always do is you always type is, let's say, for example, amazon.in. That's amazon.in behind the scene converts to an IP address of the server. Now, you don't know, right, what IP address this amazon.in is mapped to, but it takes behind the networking side, it converts into that, and that is the service does by the Route 53. The last one is a VPC, which is your own virtual private cloud, that any service which you launch, you want to launch in your own dedicated and secured network. The next what we have is the next pillar is around security, identity, and compliance, right? So this is, again, I mean, so far we spoke about the, I would say, management and other stuff. This is more around the security part of it. So anything like, I'll quickly run through the couple of services here for your just understanding, and a couple of them are very important. Artifacts is like one place where you can get any sorts of document from a compliance point. Now compliance can be anything, like we understood in the previous slide that compliance can be that, okay, my data should be only available to me. It should not be available to anyone else. That is a kind of a compliance. So if you want to understand any sorts of compliances, that kind of documents are available in Artifact, AWS Artifact. Then you have the certificate manager. Now you always see, right? Have you ever focused that, okay, when you try to access a URL in your browser, there is a lock icon on the left side, right? And if you click on that lock icon, you see a certificate. That certificate is, let's say, it is provided by XYZ bank or XYZ to a person, right? So that is a certificate manager that ensure that any sorts of traffic is very secure with the protocol, either SSL or TLS. So if you try to click any of the service, right, try to do web.whatsapp.com, you will get a lock, and click on that lock and you will see that certificate. You will get the complete detail by whom the certificate was given to, to whom the certificate was given to, what is an expiry of that certificate, and what encryption standards are. Those kinds of detail you will get if you click on that. The next one, what we have is the Cloud HSM. Cloud HSM, I would just say in simple terms for you guys to remember, is an hardware security module for now. Let's say if you want to have MFA, right, a biometric. Most of the places you have a biometric, right? That's like a hardware kind of a way to authenticate. Similarly, cloud also provides some way of hardware mechanism to identify a person in simple terms. Cognito, again, simple way to remember, right? Cognito is another service. Like certain times you see that they provide the option of sign in with Google, sign in with LinkedIn, sign in with Facebook. Those are like a SAML provider. So AWS also provides similar service to implement that, which is AWS Cognito. Again, detective, guard duty are the same stuff that you detect the entire, I would say, analyze and understand how the resources have been behaving, collect logs and track it. Guard duty is more on similar lines to ensure that whatever you have spinned up, it is not being getting hacked, and it helps you to monitor that on continuous basis. The important, this is a common service which everyone knows, IAM. IAM is like, if I explain very simple of it, now you have a username and password, and based on username and password, you have a kind of a permission that you can only access a particular, let's say, a particular location of a server. So those kinds of setup you can easily do with IAM. Like you can track it at how many people you have, what different permissions they have, those kinds of things you can do. I think inspector is similar kind of a stuff. We spoke about the trusted advisory in the previous section. Inspector is a similar lines that if you want to have some person who reviews your account, gives you the feedback that, okay, this is what you can improve, that is inspector. Macy is more like, let's say, for example, your credit card information is stored in S3 bucket. Now you want to be pretty sure that those kinds of detail does not get stored into S3 bucket. And if it is, then there is a proper security being taken care. Messy is that service. What it does, it goes in all the S3 bucket of your account and identify which bucket has any sorts of personal identifier, maybe phone number, maybe credit card, maybe email ID, maybe Aadhaar number. Those kinds of details are there. And also which buckets are public also there. Public means someone can access it from the external world. So that is Macy. Shield and WEF in simple, this is more for your endpoint security. Endpoint is like an application. Like if you have developed a web application and you want to ensure no one try to hit that particular API or do any sort of an attack, there exactly Shield and Web help you out. Here we end the security. Next interesting one is the storage. Now storage, I think S3, we all know. Glacier is more like an archival service. Is another offering from S3 itself, more of an archive. So there are certain way, like for example, simple example is you would have seen that your parents would have been archiving or saving the IT filings, right? It might be possible that 4 years, 5 years down the line, those IT filings may be required. But there is what you archive. You save it for any sorts of future references. It may or may not be required, but you save it as for the need. If there is a need or there is a requirement. So that way, S3 glaciers are in there. The difference between S3 and S3 glacier here is, just in case if, we are pretty sure that there might be a request and that we have to provide in let's say a week duration. But in case of S3, it's a frequent way that, okay, I need every minute. Versus in glacier, maybe once in a year, maybe once in 7 years, or may not be even required. So there exactly glacier help you out from terms of the pricing, from terms of the cost. EBS and EFS, I will cover in one section, is like you have an EC2 instance. EBS is a dedicated volume to attach to one instance. It can be only attached to a single instance at a given time. Whereas EFS is like a shared volume. Like you have a networking file system in your on-prem site, which is connected across all your servers and everyone can access, like shared drive, what we say. That is EFS on AWS. Then Snowball and Storage Gateway. For Snowball, it is simple. Let's say you have millions of documents, which instead like terabytes of data, and you want to move towards cloud. Now, if you start shipping via your laptop, it will take you almost like 4 to 6 months to ship that data. Storage is like Snowball is like a physical device, right? Like a tape kind of a physical device. You move all, let's say from your laptop, all the data there and send that Snowball device to the AWS. AWS moves to the required S3 bucket. So that's a more faster way. Storage gateway is more like a synchronization that you have certain files, like maybe some GBs of files, which you want to back up on AWS. You want to leverage AWS as a backup. That storage gateway can help you out, right? Next easy one is around the analytics and application integration, like things like Athena, EMR, QuickSight. I would say these services will help you to understand the analytics part of it. Let's say you have some data set. You want to query that data set. You want to do a big data processing on the data set, or you want to do a visualization start. Like let me draw some chart around that data. So that are the services provides under analytics. Athena is used for querying the data. It's completely serverless. Let's say you have any CSV file sitting in S3. You don't have to do anything. Just spin up Athena, point to that particular bucket, and you can query the data. EMR is for the big data processing. QuickSight is more from a BI application standpoint, visualization standpoint. The next two is more from an application integration, like SQS and SNS. SQS is more for controlling the request. Let's say you get 10 million or let's say 100 lakhs of different users of applications. It's highly difficult that you can allow that many users to your application. So what you do, you capture all the requests, put it into SQS, and from SQS, you funnel them. That, okay, at a given time, I will only allow 1,000 users to this route. That's a queuing, right? Generally, this live example will be the call center. When you call them the call center, you get a kind of intimation that you are in a queue. Please hold the line. So that's a queue, right? And even though I have 100 users, but I have only 2 operators at a moment. So rest of the people are put on the queue and only 2 can interact with them in a given time. That similar concept is SQS. SNS is more like a notification. Like, okay, you get certain messages, email notification, those kinds of notification. If you want to enable that, then you can do it via SNS. AWS container services, like if you want to have Docker or Kubernetes, then these are the 2 services which have been provided by AWS. One is the ECS, which is more like Docker. If you want to spin up Kubernetes, then EKS is the one that has been provided. The last one here is the customer engagement. Customer engagement is like I spoke about the call center, right? The IVR system, interactive voice system, where call center, like someone pick up the phone, guide you, help you, those kinds of things. So if you want to enable that kind of system also, which is very important in this current COVID phase, right? That, okay, you, instead of physically going to bank, you want someone, customer reference or customer manager, to help you on the live phone itself. Such kinds of solutions are very important. I will say these are in first of the top 5 solutions in the market nowadays because of pandemic. So AWS Connect is a very good service that help you to build that such kinds of system. So here we end our today's session, which was more around the AWS cloud computing introduction, AWS introduction, and different AWS services. Today's theme was more around the introduction part of it. I will share the presentation. Please go through that if you get some time. In upcoming sessions, we will deep dive in each of the pillars, which are very important, starting from EC2, storage, and database. We will try to do some quick demo, hands-on exercise, and we'll have more interactive sessions in upcoming weeks.
I would really like to thank Mr. Sanchit Jain, who spared his precious time for us and delivered such an informative session and be a part of our AWS Cloud Practitioner Training. I am sure all the students really enjoyed and learned a lot from this session. I am certain that your knowledge will help them grow and understand the subject and its concepts with utmost simplicity, accuracy, and clarity. I would also like to thank all the learners who have gathered here to learn and make the most of this beautiful opportunity. Your presence made this evening successful. We will update you with the time and date of next session. Thank you.
Yeah, sorry, Anchal, I think there are 2 questions which are there on the screen. I just saw it. Let
Sure,
me
sir.
cover that up. I think one is from Aditya. Does serverless computing comes under SaaS? Ideally, no. Serverless, I wouldn't say it's come under SaaS, because in serverless, if you go back to the serverless pillar, application is also served. You don't have to worry about the application like Gmail. So serverless is not under SaaS, you would call it out, right? That's a function as a service. That's a different thing which is coming out. I would say ideally it's coming between your platform as a service and a kind of a software as a service kind of a thing. The only difference is in Lambda, you have to write the code, right? The application. The next one, which is around if we launch an EC2 instance or any other AWS services, then is it created for a region or a web application? It is created for a region. Okay, so I'll explain you how exactly it is created in a region. So first, when you launch, let's say, an EC2 instance. So in case of EC2 instance, by default, in a AWS console, you select with region. Like you are selecting a Mumbai region or any of the regions around it. Then after you select a region, then you select an availability zones, which data center you want to deploy this specifically. So ideally, I would say it's on the region level, which is the parent thing, and then the availability zones, which is on the child level. The availability zones is more from a data center perspective. So it's both, I would say, but broadly it will be based on the availability zone which you select. It will get deployed within that availability zone under the region. Can we use code commit on CLI? Exactly. Any services which are provided by AWS, you can use on CLI. It's exactly right. I mean, very simple. You all guys been using GitHub, Git commit, Git clone, Git push. Those are the commands. The same commands you can use in code commit. There is nothing different of what you have. It's just that this code commit is already there in AWS console, and you don't have to spend up additionally. But when it comes to interacting with that service, it's exactly the same what you get it. So I think those were the questions. Any other questions do you guys have? Cool. So yeah, I think thank you guys. Thank you so much for being a wonderful audience here and asking valuable questions. I'll request please spare some time and go through the presentation so we can have the next session very valuable for you guys. And then will be able to connect the dots here. Thank you so much.
Thank you, Sanjay.